Hey everyone, day 9 of Advent of Code 2025 today. Sorry, starting a bit late, so just jumping straight into the problem. No prediction today. We have numbers, some of these are red. They'd like to form squares, rectangles. Any two that are red. Okay, cool. That does not seem particularly difficult. So basically, we just have two numbers. Let's split on a comma. And then we can have a list of coordinates. Alright, so then we just do the chords, add new coordinate. Good old integer.parseInt. I should probably write a helper method for this at some point. Oh well, not today. For all I know, I already have a helper method, to be honest. I haven't looked at the coordinate class in a while. And then we just simply do the brute force way, right? And it's kind of a sad day to start late. I feel like this is a very simple problem. It's alright. Let's see. So we want long size equals long, not like that, long of chords dot get I dot x minus chords dot get j dot x times parentheses chords, and then we just do the same thing for y. And then of course we do want to do math.abs. Cool. It's a chunky number. Ooh, and it's not right. Why is it not right? Oh, +1. Ah, so I probably want to do the math.abs in here. And now we can get rid of that. I believe there's a 1 minute cooldown, so honestly, might as well try the example in the meantime. Well, I'll run it and check if there's a cooldown, I guess. That's probably the smartest approach. There is a cooldown. Okay, cool. Let's try the example. Gives 40. That's bad. Well, thank goodness I didn't input it directly, huh? Nice. Alright, part 2. You can only switch out tiles that are red or green. Every red tile is connected to the red tile before or after it with a bunch of green tiles. And everything else is green. Oh, interesting. So now you need like a path. And it has to be red or green. Okay, and that's much more interesting. I don't see an obvious approach to doing this, to be honest. Brute force clearly doesn't work. These numbers are gigantic, right? We'd have to fill in 4 billion cells with red or green. I'm just trying to think of what properties exist here. Wait, but the corners still have to be red, right? Yeah, the corners. Well, 2 of the corners have to be red. not necessarily all of them. So we end up forming some sort of bounding box, right? Oh, but how do you determine something is a loop? That actually seems highly non-trivial. It's quite challenging. Oh, the numbers are quite interesting, actually. They form quite a peculiar pattern. It's like the two x coordinates are the same, and the two y coordinates are the same, and the two x coordinates are the same, and the y coordinates are the same. I feel like we can exploit that property. And it does wrap around. Okay, so what does that mean? That means we're always going at right angles, right? Yeah. Which is quite something. I'm trying to think if there's an obvious way to visualize this. Like, it seems kind of tough. Hmm. 9523. Yeah, I mean, it feels like it should just be like an adjacent pair, right? Like something like that. Maybe I can try that. So I chords -1. So we want specifically, what do we want? No, actually we can go through all of them. So we'd have coordinate first equals, of course, just, no, just the coordinate. Coordinate second would be, so we gotta be a little careful here, because we want to do I plus 2, but we gotta account for wrapping. So I think we do mod chords.size. So yeah, chords.size will go to 0, and yeah, I'll go to 1. And now we do, I think, like maybe this works? I have no idea, to be honest with you. Hopefully. Math.abs first.x minus second.x plus 1 times parentheses math.abs first.y minus second.y plus 1. Oh, this should be size. Yes, I only use it once, but twice, but I like it. If size greater than answer equals size. I can do math.max as well. Should have thought of that, but it's fine. Let's see what this gives. It's probably not right. Yeah. Is it even right for the sample? No, it gives 35 for the sample. And the answer is 24. So I guess that doesn't quite work. Why doesn't that work? Basically, you take this point and this point, and this point doesn't necessarily work because it's not necessarily in the loop. In fact, every other one is not in the loop. Oof. Well, no. Sometimes two different pairs are in the loop. What makes a thing in the loop or not in the loop? Ugh. That seems extremely difficult to track. How many people have gone this so far? I'm curious. 33. Yeah, okay. Part 2 is significantly harder. How can you track? How can you easily track the direction, right? Because basically, I don't even know how to express this. Like, I guess you need the previous line segment to be. I wonder if we can encode the loop as line segments plus direction turned. Like this is a line segment of some length, then you turn right, then you turn left, then you turn right, then you turn right, then you turn right, you know? Like even with all that, like how does that help? I'm not sure. I guess it's like you need to ensure that there exists a y that is outside the box on this side and a y on the other side. So obviously you can always guarantee one of these with these, right? You have this one, but then you have no y anything here. Okay, we can try that. Again, it's kind of, I don't know if that really holds. But yeah, so basically we just take a point, take another point. And then there's like kind of, there's not that many cases. Either this point is greater in, you can go like up in x, down in y, up, yeah, okay, so there's basically only 4 cases to consider. Cool, so we can kind of do x's dot add, and then this part. And then of course y's get the other half. Cool. Now for coordinate length, we still have our 2 coordinates, right? But, and we have our size. But rather than just checking, okay, if size is greater than, now we need to actually check. So we have, what do we have? I mean, we have 4 cases. Let's just write them. I know this is not ideal. All right, let's write out our 4 cases. Now what? I literally just erased the symbol to rewrite the same symbol. Let's not think too hard about it. Okay, so first dot x is greater than second dot x. And first, that means what? We've gone down xy's and down y's. So basically need to confirm that there is something at first dot x. Oof. Okay, so we want coordinate middle equals basically this, but with +1. So if middle dot x equal first dot x, then basically we need to check for the other one, right? So this covers this case. Actually, we need this all of them, so I'm down to just kind of shove it in there. Okay, so if we know this case is covered, what is the point we need? We have coordinate needed point equals new coordinate first dot y, no, second dot x, first dot y. Oh, also this is should be x. Yeah, sure. We should just. Let's actually just do this. Oh my goodness, where am I? Why? Okay. So coordinate. Let's do this actually, and if they're not equal, then we do needed point first dot x, second dot y. Okay. Now we have our needed point. Cool. Okay, now with our needed point, we need to figure out which direction out it needs to be. So now we do for in j equals 0, j less than, I guess x's dot size, they're all the same size, j plus plus, int x equals x's dot get j, int y equals y's dot get j. Right, so now if, and now this is kind of the important part, if something, then answer equals size, right? And the if is going to be different for each one. So if needed point dot x something x and needed point dot y something y, that's what we care about. I just need to figure out, well, what it is, right? Okay, let's take the first case as an example. So let's actually just kind of give ourselves a lot of space to work with. So let's say that we have a point at 1, 1, and then it goes to 1, 0, and then it goes to 0, 0. What point do we need to check? Well, we need to check 0, 1, which is fine. Our logic already checks that. But what about 0, 1 do we need to check? Because basically right now we have 0, 0 is there. I'll do red. 1, 0. I'll do green. And the next line we have question mark red, right? So we're curving this. We basically need something here, right? So this G is 1. No, this should also be red. What am I doing? Yeah, so basically if the curve goes, say, this way, then we're doomed. But if the curve goes the other way, we're fine, which implies we need some point here. The tough part is the curve, like this shape might have enclaves inside of it. Gosh. Yeah. I don't really know how to think about that, to be honest, so maybe we just don't. So, okay, this is 1, 0. This, therefore, is 0, 1. So we need a point that is less than 0, greater than 1. What does that mean? Less than 0, greater than 1. So if this is 1, 0, my brain hurts. Okay, so that means the pause, like going right. So this one is about going right. So if we're going right, we actually need, so we need less than second dot y. No, needed point is second dot y. So the second one needs to be greater than y. Yep. What about x? So no. X is what we care about. We want x. We want needed point dot x to be greater than x. Yep. And then for y, we want it to be big. So we want needed point dot y to be less than y. Oh, that really hurts my brain. Okay. Huh. Okay, well, the good thing is this case should be just a pure, oh my gosh, wait. No, but the needed point might be the other point, right? Like if it's here, then it's the exact opposite. Oh my goodness. Okay, so this only applies for if middle dot x equals the first dot x. Then we do this. Otherwise, it's inverted. Oh gosh, this is horrendous. This logic doesn't even work, but I'm like committed to it now. Okay, well, we have this gargantuan mess now. Absolutely no idea how I'm gonna logic my way through these cases without exploding my brain. At least this one should be relatively simple. No, not that one. This one. If they're both flipped, then it's just the inverted idea, right? Like we have this point as second, this point as first. So if we have this, it's the same, yeah, but with second and first flipped. Yeah, I buy it. So we just need to flip all these signs. Okay, now we gotta work out the middle cases. Actually, I'm gonna keep this open. Oh, no checkpoint. Okay, so now we have these middle cases to think about. Let's consider this middle case first. So we have first dot x is greater than second dot x. Cool. But it's less, so we basically have this case. Okay, so let's consider this one first. This means we have 1, 0, we have 0, 1, we have 1, 1, and we have a question mark. So we need something less than 0 for both. Right, so this case, by the way, is middle x is equal to first x, right? So in our point, we want the needed point to be negative, negative. So we need less than, less than. Right, which means the other way around is if we have this point, in which case we need greater than, greater than. Cool. Alright, now let's just invert it. So we had less than first, so therefore we must have greater than first, and then we have less than second. Boom. That works for the sample, which doesn't say that much. Have I guessed this already? Dang it. Okay, so I think my solution is wrong, typically not that this particular thing is different. What could I do? Oh, a lot more people have gotten it, which is a good sign. I don't know. I don't have a great sense of when the loop completes, like what's in and what's out. Because theoretically, you could almost like form an enclave, as I said, right? And it's like kind of hard to tell. I don't actually know what's wrong with my logic, though, right? Like, if I can find any point on this side, does that mean we're good? Like, if I take a look here, right? If I have this and this, we have points, so we're good. What about like, what's something like here and here? We indeed do not have anything here. Or here and here. Oh, it's or equal to, right? All right, one sec. Let me. I need to add a bunch of or equal to. That's unfortunate. but it does make sense. Cool. Hide everything. A lot of equal signs. Actually, we should check. So I put 6. I think I need to put in 16. 8, 10, 12, 14. I do hope this gives you a sense of what kind of coder I am. I'm always about that brute force solution. Oh crap, that's the same exact answer. That's bad. Also gives us the correct answer still for the sample, but oh man, I was really hoping that would work. I'm not gonna lie to you. But there might be something even bigger, right? That uses like some other coordinate. Like theoretically, what if there was a coordinate like here? You could have used these two, right? Which are not adjacent, if that makes sense. I was gonna say, oh, we should just use like the Pareto points, which is like all points on the outside, but that's just the red points. Like that's just the same thing. Well, maybe that's right though. Like maybe I should be doing that. Just check every 2 points if there's a point on one side and on the other, right? Oh, that logic is kind of annoying though, no? Is it? No, I think the logic's actually easier. Wait. Oh, my brain hurts right now. Like, if I have just 2 random points, right? How can I know which direction to check? I mean, here would be greater than one way and less than the other way for both. Ugh. Okay, we can do that. Wow, this is gonna be annoying though. Oh, I shouldn't use J, I'm using it further down. This still feels horrendously wrong, by the way, but I have no way. I can't think of why, that's the problem. The coordinate first, coordinate second. No need for a middle coordinate. The size is still correct. Okay. So basically, okay, let's just always have one of them be greater than x. If first dot x less than second dot x, we'll do int temp equals first dot x equals second dot x. Second dot x equals temp. And then we do temp equals first dot y. First dot y equals second dot y. Second dot y equals temp. Cool. So now we know that first dot x is always greater than second dot x. Cool. Now, if first dot y is greater than second dot y, we have the sort of dual case. So annoying. It's because of this nonsense. honestly, whatever. Just get rid of it. Cool. Else, there we go. We're back to it. Okay, so first dot y greater. Okay, let's do the else case first. That one I think is actually easier. Basically, just need to check for int j equals 0, j less than x's dot size, j plus plus. If what is this? So we have coordinate c equals no. We have int x equals x's dot get j, int y equals y's dot get j. And we basically just have 2 points we care about, right? We have coordinate c1 equals the bigger one, so new coordinate math.max first dot x second dot x comma math.max first dot y second dot y, and then we have the other guy. Math.min. Yes, it's duplicate. I get it. The thing is, we need to make sure it's not one of the coordinates we've already checked. So if j equal I or j equal k, I think we just exclude these. Like, yes, this means that the single line case is gone, but I feel like it's very unlikely the single line case is the biggest. I mean, there's no chance. These lines are 10,000, and I think the largest number is going to be in the millions. Maybe billions. I don't know. Okay, so continue. Otherwise, so if x greater than c1 dot x and y greater than or equal to y greater than or equal to c1 dot y, this is our max, Boolean max, false. Max equals true. If x, now of course the same thing but less than, min equals true. Cool. Nope, I never made a min. Boolean min equals false. If max and min, answer equals size. Cool. So that's half the cases. Now I gotta do this one. So this one we have still 2 coordinates. Now we would just want first dot x, second dot y, and then we want second dot x, first dot y. No, yes. Okay. And again, we have some similar logic. I need to work out exactly how this logic works, though. Let's think. So let's have first. Let's just stick with max and min. They don't make much sense, but it's fine. Max will be for C1. So basically, I mean, what we have right now, right, is we have, oh my goodness, r dash 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 r. Okay, so we have this point, and we want it to be greater than the bigger value and less than the smaller value. Similar here, greater than the bigger value, less than the smaller value. So for the first one, we would have greater than x, less than or equal to y. And then for the second one, we have less than or equal to x, but then greater than or equal to y. Okay, I mean it works on the sample, but a lot of stuff works on the sample. I don't know how much I put in that. Dang it. That's actually very frustrating. I really thought I had it here. I don't have a brilliant idea for another approach, honestly, at this point. Nor do I see why this is necessarily wrong. 1,000 million billion, 4 billion. I mean, it vaguely feels right? I mean, our ranges are on the 100,000 ish, yeah. So if we think about like 100,000, 100, 1, 2, 3, times 100, 1, 2, 3. That's like 1,000 million billion. Yeah, that's like 10 billion. So we're saying it's about half the biggest size, which seems kind of reasonable. All right. I don't have a great idea. Yeah, tough day. What other approach is there? Like, I feel like I have to use the loop somehow. I really don't want to have to find the loop. Then you have to use like ray tracing or something. Ugh. The annoying part, it's not the biggest rectangle in the loop either, right? Like that's pure ray tracing, because like here that would be this, but you don't have a thing there. So it's like, how do you possibly do that, right? Like, it doesn't make any sense. Wait, I just realized something. What? This one is 4.7 billion. Oh, that's 4.5 billion. I mean, that feels reasonable, right? Like, there's some big shape. It's a little smaller than the biggest one, but not that much smaller. No, I see why though. Like your loop could go like in and then weave back out. So there's like dents and craters. Okay, yeah, I'm throwing in the towel. Sorry. I mean, I solved part one. Obviously, a very simple part. Good luck to all those who solved part two. I'll end it here. You can check my GitHub repo if I ever do end up solving part two, but nothing comes to mind right now. See you guys.